Hello. Good morning. Um, it's another day of Advent of Code. It's day 7 of Advent of Code. So let's get into it. Okay. So day 7. As we do, I'm going to keep quiet and read a question. And then when I'm done, we can talk about it later. So yeah. This is- Perhaps you can delete some of the files to make space for the updates. You browse around the file system to assess the situation and save content of now output your browser inputs. For example, CDLS. Okay, so you browse the file system to access. Save the result. The file system consists of a tree of files, plain data. This is a very long problem. Yeah, but I get the gist of it so far. Moving on to the output. Right. A tree. Lines directory A. Okay. It's CVA and LS there. Directory A. All right. So after doing that, file with size. Okay, okay. File directories and which is NA. Since there probably to find the directory that are good candidates for deletion. To do this, you need to determine the total size of each directory. The size of the directory is the sum of the sizes of the files that contains directly or indirectly themselves do not have any intrinsic size here. The total size of the directories above can be found as follows. So the total size of the directory E is 584. Right. It contains I. Right. Directory D has a total size of this. Okay. Find all the directories with total size of at most 10,000 and then calculate the sum of their total sizes in the example above. 100,000, sorry. As in this example, this process can count files more than once. Total size of A because okay, find all the directories with a total size of at most 100,000. What is the sum of the total sizes of those directories? Okay, okay. Let's get the puzzle inputs. First of all, I think we need to start the this 7 from the template. So basically, what I mean is this. And then rename this to day 7. Okay, And so now that we have the 7 created, we can start it inside our and obviously close this because we no longer need it. Okay, so let's put our input data over here. I don't want to update VS Code. Thank you. Oh, why did I copy? Copy, paste here. Let's save it and rename this to yeah. Um, let's get our test inputs to as well. Our test input is going to be okay. It's going to be this thing right here. And our test output is going to be solution test output. It's going to be this. Where is it? Oh, this is not our test output. So I need not to copy the whole thing. I just need to get test outputs 95437 copy 95437. So I need not to even do this. Okay, yeah. So now let's run through the problem. We've spent 12 minutes today just within the problem. That's interesting. Um, so yeah, the problem is basically traversing over a file system, right? Um, and they're going to give you like a bunch of commands that they run, and then their output as your input over here. And basically, what that means is that for like given a file system, which obviously is going to start from the root folder slash, right? The Unix root folder. Um, they will be running a bunch of commands, which is basically aimed at showing you what the file system looks like, right? And everything that you see here is, yeah, so they run ls at the root level first, and then they got the output that there's a directory A and then a file B and a file C, right? And then also containing like another directory D. So this is all output, right? Everything that doesn't begin with the dollar sign is going to be the output of the previous command. And basically navigated into the directory A first, and then did an ls there just to let you know what's inside the directory A, right? And since the directory A contains an E, did another one to there, right? And so yeah, yeah. So basically, this is going to build a very beautiful tree for us, right? Yeah. And so I'm thinking of how to like represent this in Python. Obviously, it's we are going to be needing some sort of a tree implementation, right? And we can have a, a dummy class called file system that can be used to store the objects that we are going to retrieve, right? So basically, what I mean is that roots and then nodes. Okay. Let's first figure out how to read the input, right? So yeah, the input is going to be given to us in this format. We first need to find out a way to read the input into our program. So that's the first problem that we need to solve. And then I think today's is going to be a little. So yeah, we need to store them as command and output, right? Command and output, and that's literally going to be a dictionary, right? So let's do that. A dictionary that contains the command as the that can't really be a dictionary, yeah, because what we run ls twice. How about we only need we only need this. Mm, the only commands being run here are cd and then ls, right? Yeah, so it should just be a list of commands and outputs, basically. Yeah, so let's iterate over the data like we always do. I'm wondering, can you call starts with on the let me just type in if line 0 is equal to a command line is equal to I'm going to create a new command object, which is going to be basically a tuple of the command and then its output, right? But I'm thinking here, I only need to build. I have an idea. For I in range this, um, if the line is starting with there, then it means it's a command, right? And so we loop until so we start a new command and output. I don't know what to call the variables. Let me call it var, which is going to be a tuple which contains the command itself, right? And then um, command itself, and then the output. The output is going to be um, yeah. I plus 1 going all the way to the end of the what I was thinking here. And you stop it um, when the next thing is so it's going to be a command. Output that appends data J. and it should just loop from the next line all the way to the end, right? But it should um, check if it starts with if the if the data J starts with a dollar sign break. Break the loop, yeah. Else, just keep appending the data J to this, right? So we have done this. Why is zero? Zero means here. And so yeah, temp should be this after the output. Yeah. And so this temp should be come to the next one if it finds it, it should. Yeah. So build this. Time shouldn't probably be a variable, but anyways, yeah. I didn't print it. Okay. I always forget to take out the new lines. Always. And first of all, let me clean up with the backslashes. Um, Okay, now this is ridiculous. I'm stripping. What is wrong? What am I doing wrong? Okay, this is ridiculous. I append it, I strip the new line character of it. I strip the new character of it. I know what to do. Um, Let me first just believe such a silly plan is taking me time. Oh, great. Okay, so if it starts with this, we should, yeah, I'm saying if it starts with this, we should start a for loop that will basically start from the beginning of where this one ends to the end, and I'll be checking if it starts with to break it. But if it doesn't, okay, break else, you go to output.append. Go to append output.data inside the output, and then when you are done with this for loop, that's what am I doing? What am I missing? Um, okay, let me check something. Bloody hell. I am pretty sure today's problem, half of the time will be just used um, cleaning up the data. CD. So I'm doing the right thing because temp is right. Right, temp is right. Temp contains the actual nice things. But when I do command and output dot append temp, I don't, I really don't get it. Oh boy, oh boy, oh boy, oh boy. Lord have mercy. Lord have mercy. Oh gosh. Yeah, but at least I've discovered a new potential thing that was going to cause me problems too. The new line is not being stripped from the so when I iterate about this, yeah, they haven't been yeah, so this thing was doing the right thing. Um, this thing here was doing the right thing, I guess. Bloody hell. Yeah, this is what I wanted to do. Yeah, this is what I wanted to do, and it has taken me 30 minutes to do it. Okay, let's let's get into action. Yeah, so I was saying that to to basically to try and implement this right, we should first of all have some sort of a tree implementation, right? And I'm bringing up the question side by side so that we have an idea of what we have to do. Control shift, control shift, then control shift. Now they are side by side. It will be a lot easier to. How do I minimize this thing here? Right. Yeah. It will be a lot easier to um yeah. And so yeah, basically now we have the commands and then their various outputs given to us, right? And what we actually need to confirm is that sorry is that when this thing is run, um, for each of the command and then the output that we get, right, we have to do some sort of build a picture like they have over here, right? So build a picture of the file system, right? And how I can think of doing that is by literally having a class called file system, right, which have nodes, right, and each of the nodes will have basically these ones as like these ones as a node of it, this ones as a node of it, and then the node will basically describe types, right? And so let's create that class. And again, this might be an overkill file system, but we are learning programming, so how do you spell system? And what I meant is that file system should have a root, right? Which is and um, child nodes, right? And the child nodes should basically just be some sort of an iterable, right? So child nodes, or let's call them children, right? Should be a list, right? One iterable of the type. Yeah, and so we basically have to find out a way to represent these child nodes. Let's call them. How do you classify files and folders? Into one bracket entity. Yeah, let's call it entity for lack of a better word. Entity basically should define a type, a size, and what again? And hold reference to children too as well. Okay, so this one needs to be an object instance. So let's define the initializer. Should probably be passing in the various variables when we create it, but then let's first define the variables first. Those variables are going to be self the type, right? If you don't know the type is going to be yet, what the type is going to be yet, it should probably be an enum, right? That holds and self dot. And so after the type, we also have a size, right? which is going to be an integer, and there's also supposed to be a child node. That's if it's going to have one. Um, if it's folder, then it will have children. If it is file, then it won't have some. But basically, children is again going to be a list of entity references, right? And so, sorry, self children. Yeah, should also be so yeah, this should help us build. Wait, we didn't give it a name. Type name. Yeah, and so this should help us do the trick that we want to perform here. And so basically, what we want to do is build this file system onto this class file system. And how we are going to build that is by first of all defining the roots of the file system, right? So file system dot root, and then setting it to whatever it is going to be, and then the children will also be set as entity types, and entity types can be created as this. So we can pass in the type, whether folder or file. I am going to use what they are using in DS, right? I think they are using, in terms of the output, directory, and then if it's a number, it's a file. So directory and dir and fil, maybe, yeah. Mm, yeah. So the type is going to be, yeah, dir or fil, and then there is name of the file, and um, what again? The size. That's the other thing that it takes to as well. Yeah, we probably do not need this base class, but I need it as a static class, static instance, so that I can be referencing the root every time that I want, right? And yeah, it could simply be another entity, right? But again, um, yeah, this root could be of type entity, right? Which is yeah, we definitely do not need this file system class because the root itself is going to be an entity, right? That is going to hold a size too as well, right? Do we need a size of the roots? Yeah, we do. Yeah, so we probably do not need this base class. Yeah, and so without further ado, let's dig into it. Let's start using the commands to build out this file system. And so yeah, I don't know if it is safe to assume that the first command is always going to be the slash home slash root, right? But basically, what we can do is you know what if they go to root multiple times? And that's one to think about, right? Let me find cd. Okay. Um, but anyways, yeah. What I need to do is This could have been a recursive if we were the ones running these function these commands, but it is not because they've given us each command that they've written and then its output. So we can linearly iterate through it, and then as we are iterating through it, we're building it. Let's see, it goes this way. We start with the roots. If it's a if it's a cd command, we don't really expect an output, right? Yeah. So what we need to do is iterate over the list of commands. So for command in input data, if I can do command and output in input data, and if command if the command that has been given is a is and then build a new entity item from there, right? So I created a constructor that takes all of these. If they had just given us the file system to just iterate over, it would be a lot simpler. Yeah, I mean, they could have just given us this so that we write a recursive function to just iterate over it, and then now we basically have to build out this file system first, right? Before we come and solve the problem of okay, now which of them contains something higher than a 10,000, right? Or probably to solve the problem, we don't even need to. I mean, we could simply just build out, which nah, no. You like let's go by the approach that we are going with right now. Yeah, so we are creating a new entity class with the yeah, probably not created with the size. The size can be calculated. Um, yeah. What what we can do is, create a new entity with this type is directory. This should probably be some constant somewhere. Type dot. Yeah, this should definitely be a. So it should be a directory, and then what again does it take? The type and then the name. Yeah, the name should be slash rights or whatever the name is over here. Which means the next one we should expect after a CD is an ls, right? Um, I'll just type look. Okay, what I really want to do is, first of all, if this is if it's a cd command, right, build an entity called directory, and then save the directory as the root, right? I shouldn't probably overwrite the root because root has already been defined up there. So what I need to do is add this special line root equal to directory if, because this thing only has to happen once. We don't have to worry about this, right? Oh, sorry. Um, yeah, this will only entered be this would only be entered once, so we don't really have to worry about it after this stage. Yeah, so we created an entity. It has no output, so we don't really worry about the output, right? But if it's an ls, right, that means moving forward. If it's an ls, what we want to do is we want to build upon the previous yeah, I kind of don't feel like this thing being the child makes, and like the children being a list makes sense. right? The yeah, it should probably be a dictionary for the sake of code insanity. And what I need to do is have some utility methods that would add child. How about I make this multiple entities, right? Yeah. Yeah, so that I could probably do all the entities like in one, adding all the children in one go, right? Like if I say directory A and then these are the children, right? I could probably just add all of them in one go, right? And so the key is going to be the name, and then the the value is going to be the actual entity object. So self.children dot update, um, and I need to build a new dictionary to update it with. Update it with the keys are going to be dictionary of the keys is child dot name. Why are they saying child? Child is, oh, right. Let me call this one children because it's okay. And so that's going to be my utility method for adding things to the children of an entity, right? Yeah. So yeah, what I mean to do here is that once we cd into it, we can create the entity and then put it down. Um, else, yeah. So once it's not a cd, which means it's a listing of um it's a listing of directory, right? I mean, those are the only two types of command that they give, right? ls and cd. Okay, that's all we need to worry about, right? So we can go with else. So yeah, so else we update the directory with its children, right? So else what we have to do is um, directory dot add children, and those children are going to be output. But first, I need to build entities out of the outputs, right? Because come on, these are strings literally, right? Um, yeah, these are strings of types like or well, there's a list. I could do it in here, right? Yeah, probably not do it this way, but do it this way. I should be able to pass in a string, right, of whether it is, yes, I'm going to create new entities, children, child, or, and what I mean is that I'll first split it. This might be some nasty ass code. So split it, and then after I split it, cast it to a. I've split it into name and type, right? So yeah, so yeah, nah, definitely do a separate for loop for this, instead of trying to make everything so simple in here. And what I can do is that I can have some temporary variable that I'm going to split the child inside. Right, once I've split it into type and name, right? Let me split it first. Child 0 and then child 1. The child 0 is going to be the type, and then the child 1 is going to be the name. So I'm going to create an entity object out of that. But before I do that, I first need to make sure that, yeah, so if the child 0 is of type what? Type string, right? So they are both going to be strings at this point. So what can I do? It's definitely going to be, yeah, dir. Then I have to create a new entity with name with a type, and then the name is going to be name, and Yeah, and then I'm going to put this one in my temporary children collection. Okay, children entities that append this entity, and yeah, and if it is not, and then it is else, we cast it to a file, to an integer, sorry, and then that becomes a size. And then we save this size into a new children entity, right? So yeah, we create. Right, so we've created and then set the size, and then now once this entity type has been finished building, right, we can go ahead and then update it inside. So let's test it out. Um, yeah, so let's test it out over here. Directory.add children, and then we pass in the output as its arguments. Right, so if it's a CD, it comes here. If it's a okay, so let's find a way to print out the entity roots. Right, let's define a way of printing this one over here so that we have a. And how we do that is by defining overriding the toString method of this one. Um, for the representation, right? Basically, how this is going to work is we should first probably print out the name. This is definitely going to be an iterative function that will basically go through, start from the top. If you want to print an entity, we should print the name, right? So should build it out this way. It should first of all add the name to it. I'm just trying to print it exactly as they have done here. And then the name comes, and then the type comes, right? Okay, and so yeah, once we've done this, we can go ahead and then iterate over its children and then call the um yeah. But I don't want to just add the children in there. I want to iterate over the values. Right, and then print the values too as well. So for each of them, I need to call their string method. Right, and so str child for child. Yeah, this is what I want to do. I didn't add a new line after this thing has been printed, and so this should do it. Okay, built-in function. It's not iterable. What am I trying to iterate over? Oh, okay. Well, where did I write that nonsense? Which line? Line 55. I've written some nonsense in line 55. Input data. Yeah. Where am I calling split? Child dot split. Line 26. What? A child in children. This is already a list. I called append instead of append. I called append again. Where did I do that? String object has no attribute name. String object has no attribute name. Why am I doing that? Line 34. Why are these still? Oh, because I'm supposed to be iterating about children entities. And then what else? Return non-string type. Okay. Let's see what I'm doing here. Why is it returning non-string type? First of all, let me print out what this is supposed to look like. Am I doing any other print? It's empty. Self children dot values. Already called our children, right? You for now, let's comment out this and just make sure this thing has been printed yet. What do you mean return the non-string type? Okay. Oh, that's incredibly funny. Yeah, what are we printing out over here? For some reasons, my name and type seems to be empty. Bloody hell! Type name comments print. Okay, so yeah, at least the root is printed fine. Root is this, and it has A, B, and C and D, right? Let's look at the test inputs. Root is this. It has A, B, C, and D. Yeah, so root is printing fine, which means I clearly need to fix the indentation when it is printing out. Um, but that's secondary. That's a problem that we can definitely solve later on. Um, Yeah. The main problem here is, wait, what? Why is b.text saying directory? Um, yeah, b.text is saying directory, which is funny. Which means then else we should create a new entity. Oh, that's my fault. I didn't put in the file here. File int e-type new child size has been set. Yeah, so this should be a lot better when I print it out. Okay, file. Okay, file and size, right? So here we do an if, and we add this if it is type this. Else it should be oh, I think this part can still remain up there. And then we close it if it is directory, else we add a comma. Else we add a comma, a space, and then the size. I'm kind of thinking everything here could have actually been an F string. Yeah, and then add the size before closing it, right? And add a new line to it. Okay. And this should fix the problem of the size not being added. Okay, just like we have it in there. Okay, right. The problem of indentation, I really don't have any idea of how to fix. I'm going to leave it for now. But the problem of the children not being, I call a string of the child in self dot children dot values. Yeah, unless the entity B or entity A doesn't have any children. So let's print out roots dot children. E. Right. Yeah, let's print out this particular one. It has no children. Yeah. So the children entities are being skipped. Let's see why. Let's look at the input data first. We get into A and then we do the same there. Right. But for some reasons at during this stage, during this stage, because entities are being created over here. So it has this children directory A. I'm taking too long to do this. Um, let's see. I'm going to look back at this and really laugh. Like, what the hell am I building? Directory A 148. We've built these entities, we've put them there. And directory E is going to be okay. And this one has directory E inside it. Which means it is called with all of them, right? Yeah, our children is called with all of the children. Okay, and so let's just say if it is called with E, what is going to happen? This is This method is obviously called, but they never get added to the A. Okay, and why is that? Let's look at the add children. It has been called with E all the way to H, right? And then E is child and children if E type. And okay, so if it is a directory, you should build an entity directory and then give it a name and then put it inside children entities over here, right? Okay, then when they are done, it should call them. And if it's not a directory, it should get the size, update the size, and then append new child. It's going to be an entity to the children entities list. And when you're done, for child in the children entities list, add the key value pair to it, right? Unless this function here is not working. Um, how about instead of calling update, I mean the children will will ever be only be. I think there's a directory from the previous. Yeah, cd into A. Yeah, that directory. Oh, it doesn't happen in the for loop. Child, yeah, it's not supposed to happen in the for loop. A child and children. So what is the problem? Let's print the entity at this stage. Okay, so it does contain everything. I'm wondering why this thing is not being printed. Um, root children a dot children is empty. Why? We do not know. How about because from the output it seems A does have children, doesn't it? Yeah, this one has children, A, B, C, D. A has children, E, F, G, H, right? E has children, I. Maybe it's just my to string which is being problematic. So I'm saying loop over there. This part is going to be a problem. Let me mute the other print statement. They all don't have children. Why is that? Yeah, they all don't have children. I'm printing out A, right? So I'm looping through the children of the root, which is supposed to be A, B, C, D. And then I'm saying, okay, print out the children of A. Oh, print out. Now we know for the first one is it's supposed to be empty, and they are all empty. They are all empty. Yeah, I'm clearly making some silly mistake somewhere. But this is clearly supposed to work, and I'm taking hours to debug it. So I'm definitely going insane. Yeah, definitely going insane. Um, After I have called our children, let me just print out this and see. Okay, yeah, basically after I have called add children, let me call directory dot print children and see what's inside it. Wait, that's containment. um, so A contains four things, clearly seen here. One, A, B, C, and D. Right. Then when I call with E, so this is after the first one has run. Let me first print what directory is first. Yeah. So slash has these children, which makes sense. E has these children, right? Oh, loco. It is my fault. This this A entity here is not the same as this A entity here. Loco. Yeah. So basically, I see the problem. The the A entity, the A entity from the first one is not the same as the second one, right? And the reason for that is because when we cd into any directory, we create that directory, right? So let's just say we've created a slash, so a slash we have assigned it to root, right? The next cd that comes is an A, right? So we've created a new A, right? Um, cd slash ls. Yeah. So using this test input as an example, cd slash and ls, we've already created all of these entities and then updated them, right? Yeah, so I have to do something when it's an else, right? When it's not the the, the roots, right? And that is going to be, instead of creating the entity here, yeah, instead of doing that, what I need to do is get the directory to be fetched from the roots, right? So you get it? Yeah. To get the location from it, right? And then we can use that entity as a new directory. Oh, blabby, blabby, blabby me. And let me print this one out. Let me first. Let me first comment out this, and then print this one out. There's none. It should definitely be an else statement. Because if not, we are going to copy over the directory into here. Okay, what am I doing? What am I doing? Um, line 68, add children. Object none type has no attribute, add children. One of these things is returning a none. So using this data, if it's so the first one comes slash cd and slash, right? So it's a cd, it's a slash, so this happens, right? And the root entity is created as dir, and the loop continues. For the next one is going to be an ls, which has no second part, basically, right? But that has a bunch of output. So else our children output directory our children. Yeah, the root was still slash, and then now I am using it. Oh, it's not CD, so it won't even enter here. Right, right, right. I mean, now this should happen anyways, right? If it's a CD, this should happen, and then we assign it to dir, right? If it's not the case of a slash, what do we want to do with it? If we want to get it from the previous one, right? So we want to do. Oh boy, think. Let's let's put it down in comments. Maybe it might simplify things. What is happening here is that when we want to add the children, we need to select the directory to add it to. So between the yeah, I should probably just have a variable in between the loops, right? That's yeah. Let me have a variable called current working directory, right? And then basically what I'm going to do is that when there is a CD happening, right, I always just update the current working directory. If it's a slash, we update it to this. If it is not, this is hilarious. Someone just said, "Good luck, my dude. It took me a while to solve today's problem." Yeah, it's definitely a tricky one. It's definitely a tricky one. Uh, but yeah, we are definitely going to put through at some point. We are going to have to put through. Uh, so if it's a CD, then we change the current working directory. You know what? Let's forget about this root thing for now. Let's focus on the logic of changing the directory, right? Okay. So if it's a CD, we create a directory object, and then we change the current directory to this, right? If it's not a CD, which is an ls, right? Then we instead of calling it on this, we do cwd dot add children, right? and the root is going to be used. So let's just say we create a slash directory object, we put it inside the current directory object. This one is going to be an ls, so we come here, we add children, right? We add the children to the working directory, right? Then we update it, yeah. And then now we can we only just set it once, right? We don't need to change it ever again. Okay, so yeah, finally we have something printed out. The root is being printed out, right, but the the children again are not being printed. And why is that? It's going to be a new instance every time. What we really want is to not use a new instance, but then use, change working directory to, yeah, we need to have a way of git slash we create it, right? If it is not, we get the roots dot, we get the we need to find a way to change the working directory from dir receiving it. Why was I using dir the whole time? Yeah, so and then set it to the current working directory, and then every time how do we change directory into the new directory? If it's a slash, we do this. If it's not a slash, we want anything else, right? Then we look inside the current working directory, then we find the children and then put it in there, right? It should always contain an empty object. So we should look inside the current working directory and look for the children and get location, right? And save it inside here. And this should be the else block. Oh boy, this is silly game, silly game. Has no attribute children. Why is it still none? I'm saying if it is, so I've gotten the location, and if it's a slash, right, build, assign it to root. Okay. Maybe that didn't sit right with. Okay. So CWD has something. If it's the first time, it is a CD and then it's not a root. CWD must have something. It must have something. It's an entity. Oh boy, how does an entity not have children? Let's try and see why. Um, so let's see the first input. So we have called CDA, right? CDA. CD is in the command, right? So it has come here, and it is the location is definitely not a slash. It's an A, so it comes here and then tries to check. 68. CWD has no children. Has no attribute children. Oh, it's gone way beyond this. Right. Okay, so yeah, clearly this is I haven't handled the case of yes, I haven't handled the case of the CD into dot cases, right? So for these ones, I have to go into the parent, right? I have to traverse backward into the parent, right? And so um yeah, so this one works, but then when it finally encounters this part where I'm printing out the location in the current working directory, right? The location is supposed to be parent of this. So what I need to do is do an else if for that other special case, right? So else if the location is special case of dot dot, right? What you need to do is go into the parents directory, right? So how I'm going to do that is so I'm in the current working directory. Let's say I'm in A. I want to go back into slash, right? I'm in A. Um, which means each entity must define a parent, right? Yeah, each entity must define a parent. I was only thinking about it from the child's perspective because if I don't define parent, then it means I have to do a very nasty loop, right? To get to the to the parents, right? And so and then the parent will be updated every time um, an entity is being created, right? An entity is always created knowing the parent of it, right? And so in the add children at this stage, we have to basically update the child before it gets put in here, right? And so the new child, yeah, this new child's parent has to be set, and it's going to be set into it's going to be a reference, right? Um, so copy this or cut this and then make it a variable new child. And what I can do is that I can set the new child's parent to self, right? Before I put it in there, right? Same thing goes for here too as well, right? And once that is done, then it means I can reference the the parents this way, so that when I see dot dot, I can say okay, then go to the CWDs dot what dot parents, right? Okay. Yeah, and this should solve our problem of hitting this line. What? Oh yeah, one of them wanting to have a parent. But wait, line 71. Parent is not defined. For which of them? Okay, clearly this one doesn't have a parent, so I don't need to set it. It is going to be none. The location is in the current working directory. Before I print the thing itself. The location is E, so it has been seeded into E and then CWD. We have done it into E and we can't undo it from E. Has no parents. So we've seen our first dot dots, right? But our current location is E. We are saying that there is no um, There's no parent for E. Why is that? When we were creating E, we didn't assign a parent. Okay, so let's see where E was first created. E is under E, right? So when we were creating the children of E, that's when we created E. And that would be over here. At what point didn't we add here? Oh, holy boy. This is just exhaustion, right? When you make mistakes like this, it's just stemming out of exhaustion. Okay, so we've finally been able to build out our tree, our fancy tree. Let's take out the fancy print statements, right, from each of them. Now that we've removed all the fancy print statement, and let's remove this one too as well. What we can do is, print out the roots just to have a pictorial view of what is going on. Okay, so we have something exactly similar to what we have here, except with the indentation, which is fine. I, F, G, H, B, C, D, J, D, K. You have no idea how happy this one makes me. Okay, and so yeah, the final session will be just about after you've built out this file system, right? After you've built out this file system, what you have to do is now what was the next thing? I've even forgotten the rest of the question because I've spent my whole time just building the goddamn tree. Most than 100,000. Okay, so basically, find all directories with total size of at most. Okay, okay. So this is just going to be a recursive function that I'm going to write here, right? It's called find delete candidate, right? And it should take in a file entity as its argument, right? Most likely root. Right, and what it should do is that it should basically traverse over the children and then try to find which one of them has size of at most 10,000, right? And so yeah, for file fp, and mind you, we only have final directories with a total size of at most, yeah. Yeah, directories could have sizes, right? Just that they are not assigned at the beginning. So what we could do is, let's let the directories, be updated as we add children to it, right? Um, Yeah, let's first compute the sizes for it. So for child in for child in roots children. No, not you. Whenever I update the children of can I update the sizes? Yeah. Whenever I update the children, it should update the sizes too as well. So what? Oh, that's too much. Yeah, I could do. I mean, like that's probably like the best way to do it, right? I mean, if this was a production environment, right? Whenever it goes live, what you have to do is like whenever a file is added, a child is added, you update the parents, and this is the event that is updating the children. So after it has been done, you can calculate the sizes, right? Yeah. Whenever the update is done, you can set the size self dot size is equal to right now. This is going to be a list, right? And so we can just sum the sizes. And this would ensure that sorry. This would ensure that each child element has a each child element has a each entity element has size attached to it, updated size. So when we are calculating the candidate, we can always just reference the sizes, right? And so for child in roots dot children, how have I spelled children? Right. For each child in that, we should basically just be calculating be finding the size, which is what less than 10,000, right? Yeah, yeah. It has to be recursive. This is not particularly useful because it doesn't follow through to the parents too as well. And if the size updates, right? So let's go. So if we add something to the out, maybe. Okay. If child.type is entity type, and what I need to be doing at the parent level is be checking to see what the size is. Um, it's 100,000, right? Yeah. If the root dot size is less than or equal to 100,000, we can add it to candidates. And what you can do is we can return it. Okay. First of all, I need to print out each of them and then their sizes too as well. Um, yeah, and so what I need to do instead of just printing out everything here is um, call the find candidates on the roots. Right? And as I am doing that, I want to be printing out that instead. Okay, so let's run this. What do you mean has no attribute update size? We just wrote. See where we wrote that function. Oh boy. If okay, maybe I got two candidates. How many candidates were expected? Oh, which means it's working out to the best. How am I even surprised? Oh boy. So directory A and then directory what's E, which is exactly what you're looking for. Whew. Okay, so let's forget this print statement and print out the sizes. Okay, 95437 passes. First one, and then the first output is 10777191. 10777191. Okay, we've got our first star. Let's go to the second one. This is incredibly hilarious. It's taking me 2 hours 45 minutes to finish the first one. Um, oh no, 1 hour 45 minutes. Sorry. Yeah, however long it's been. My mouth is dead. Um, 1, 2, 3, 1, 2, 3. 70 million. We need unused space of at least 30 million. You need to find a directory you can delete that will free up the space to run the updates. In the example above, the total size of the outermost directory and thus the total amount of used spaces. Total amount of used. Above example, the total size of the outermost directory and thus the used spaces. This means that the size of the unused space must currently be 216.188.35, which isn't quite there. Therefore, the update still requires a directory with total size of at least 838.1165. To achieve this, you have the following options. You can delete directory E are both too small. Deleting them would not free up enough space. Find the smallest I have a directories D and slash. The smallest is D, increasing used space by. Okay, find the smallest directory that, if deleted, would free up enough space on the file system to run the updates. All right, so now we are after 249.33642. Let me comment out the input data and part 1 and just focus on trying to run part 2 with the test data. Yeah. Okay, and so what that means is that basically from the start, right, we have already computed which file size, blah blah blah. Now they said the total disk space available to the file system is 70 million. To run the update, you need 30 million, at least 30 million, right? And so you need to find a directory that you can delete to free up enough space, right? And based on the spaces available on the disk, we are trying to find which of them that we can delete that can give us 294 blah blah blah, and just go straight to the point. It's definitely going to be so fetch me the ones which are less than 10,000. Now we just need to find the smallest directory. Yeah, so we just need to find one that's basically adds up to 70 million, right? In the example above, is 483. This means that the size of the unused space must currently be 216,188.35. Okay, so I'm trying to find a number which is greater than 2166. That's in this example. So first find the difference between the total use space and then the available space, right? Okay, so let's first create those constants up here. Total space is the constant on the file system is 70 million. And then what again? What other constants did they give us? The required space is 30 million. Right, and what they need from us is you need to find a directory that you can delete that will free up enough space, right? And so basically we first have to figure out which one, how much used space that we have in total. So to find the used space, let's go to part 2. Total use space will be the roots use space. So let's, after running part 1, to definitely update the roots. Okay, so let's kind of run part 1 for no reason at all. Just so that the part 2 will be updated, right? And so roots.size should give you the used space, right? Okay. So you have the total use space, you have the total space on the device. Let me not call it total use space, let me call it just use space. The used space is given as whatever that the root is going to be. Total space is given as this, and then the required space is 30, right? So if I take the use space out of the total space, if it's 50 million, right, I'm going to have 20 million. So the difference between the required space and then the difference here is what I should really be after, right? Oh boy. It's less than 10 million. Right. And then when we find the ones that is less than 10 million, we delete the highest one. Right. Okay. Yeah, so basically all that I need is to do some calculation on here to find the minimum deletable, right? And I'm going to do that math right here. So I'm going to call it minimum deletable. And that is going to be calculated as used space, so total space minus the used space. If I take the used space out of the total space, I'll have the available space, right? And then the required. So the available space. Yeah, and so we have the available space, we have the required space. We require 30 million, we have maybe 20 million, right? So the difference is what is going to determine how much we need to delete, right? So the deletable space is, I really hate this word, but deletable space is going to be the difference between the available and then the required. The required is going to be greater, so the required space minus the available space. Yeah, that should give us our deletable space that we are after. So if let's say it is 10 million, we need to find a file which is at least of size 10 million, right? So um, that being said, we could probably extend this method here to do it for us, or we could write a new method, right? Now let's extend it. Find candidate of size, and then in the part one, put the 100,000 there. And then in the part two, this is going to return the candidate that's oh, this is the complete opposite. Right. Yeah, so definitely not. It wasn't worth it doing it that way. And then we should return the highest one basically. The highest one, no, the lowest one. That meets the requirements, right? And so the minimum of this, right? Um, First, let's print out what this thing is going to hold. Right. Let's just make sure that it meets the requirement of. What do you mean? Root is none. That was the whole point of running the part one. Just so I have roots defined. What am I doing? Uh, the whole point of running part one is just so that root is defined. What do you mean root is no longer defined? How do you set a global variable with a global keyword? Finally. Okay. And so we do have our candidates. Let's look at the sizes. Print size for each of them, right? Let's bring this beautiful print statement to come and replace this nasty print statement. So what you can do is we can uncomment this and change this one to candidates 2 and run this. Oh, sorry. Okay, so we have about the directory sizes are not candidate dot, don't print the whole thing, just the sizes. Okay, so we have 4 candidates, 58494, all printed backwards. And we want to find the ones which meets the criteria of the least required to be deleted to meet it. Wait, one is being left out. One of them is being left out. 584 is there. 94853 is there. 24 is not there. Why is 24 not there? Yes, why is 24 not there? 24 is D. Why is D not there? What is the size of D? Let's look for the size of D. Where is D actually? D is lucky for us right on the roots. Let's print roots dot children dot get D dot size. And isn't this number higher than 24933? Sorry, higher than whatever this is. So if it is higher, why isn't it getting picked up by this fancy function? Let's look at it. So we are saying it should loop through it, right? So if if my size is greater than the size that I'm looking for, it should append it to it, right? Yeah, and once you've done that, you should look at the children. So for root.children.values, if the if it's a directory, right? Look at the if it's a directory, look at the size. Find the candidate of that directory, right? So so you're saying the candidate plus, so it tries to do this with the D. Let's Let's try and do this with a D. D has nothing in it, right? So checks if the size of D is greater than this, right? Then it appends it to this one, and then comes back here. Okay, I see it. Um, I'm thinking it's definitely like needs to be passed through here as a. Oh boy, oh boy, that wasn't the problem. This was the problem. Okay, and now for a good reason, this is being left out. This one right here is being left out. I'm thinking that's a reason. 5 feet 4 is being left out. Well, let me just print out deletable space because I'm confusing myself. And okay, yeah, now it makes sense. I'm uncertain as to which which print is printing the 9534. Probably from the first one, right? Yeah. So what we probably need to do is uh, yeah. So after this has been calculated, right, and then we find out that these are the two. We need to find the minimum of of these two, right? And so basically, if what am I doing? Yeah, I can give this class a comparator that they should be compared by their sizes. And how I'm going to do that is on this one, just define an LT, right? And it should just return true if the size is less than the other size. And with that being said, what did I write? Other dot size. Yeah, and so that should be able to be used to sort this one out over here. And I just call the minimum, right? Minimum of the instance of the and then return that. Okay, right now there are a bit. Okay, yeah. So 249 is printed out. I need to probably mute this one and mute this one too as well, and run it for my output here. Oh boy, this has been one of the longest days. I'm sorry, what? How is the delete negative? How is the deletable space negative? Total space minus the used space. What was the used space of this one? Is that supposed to be the output that you are looking for? Because find a smaller directory that, if deleted, would free up enough space on the file system to run the update. Ah, well, let me just give it to them. That makes okay. Yes, that definitely didn't look right. Um, that definitely didn't look right. That's why I'm second guessing it. Yeah, how am I getting the a negative for? Let me just print out everything. Let me print out available space. And print out used space too as well. Available and used should sum up to 70 million, right? Twenty-eight nine three six three eight. That's hilarious. Okay, let me first of all mute this return statement, print out this, right, just so that I see what is returned. Available space is this, used space is that. How is it that this giant 48 million 165. This one has 28,000. 28. Yeah, this is definitely like not right. This is definitely not right. And the use space is off by at least a million mile. Let me print out root. And this is my first time printing roots after everything has been done for the part 2. Okay, now that's a very giant root. Should be a couple of millions at least. Yeah, this should be a couple of millions. How did it pass question 1 if roots was off, if the size of root was off for the first one? What? All these are supposed to be children of root. How the hell does it sum up to? This is 11 million, 110 million. What is 11 million? This is 2 million. This is These are all thousands. Yeah. Size is equal to self dot size and I'm saying self dot size should be set to size. Update size should be children dot value. You already updated the children, right? You updated the children. That's why we are creating, we are summing the size and updating the size. And after every set of children is set, right? So let's just see this. Right, after we go in here and we update these children, how has it worked for the first one and it's not working for the second one? Um, let's see. Oh boy. Um, Let me look at comments to see if anyone has said anything else. Nope, nobody has said anything else. Um, so we are here. Um, then we've updated, we've gotten this and that and that. So we've summed this and then updated. We've got updates. date size, right? Which we should set the size of this A directory to just for the size of A directory to the sum of all of these, right? So we said self the parent dot size plus equal to self the parent date size. That's what we should do. Because we are calling the parent A, and then we are saying it doesn't get propagated. Doesn't get propagated. So we update the parent size. It's going to be the A. A the size gets increased by this. Oh boy. Oh boy, oh boy, oh boy, oh boy. Doing something terribly wrong. Yeah, this is a dummy print. I don't really need it. Um, when a child size is updated, when a child directory is updated, its parents need to be updated as well, right? But it needs to propagate through, right? It needs to propagate through. So we are saying so in parent, it's already 0, right? So you have to call the parent update size with the size too as well. Yeah, now this looks about right. Confirm this is doing what exactly what you want it to do. Let's first print out. Let's stop printing these part 2 stuff. We are saying for yeah, instead of printing out these ones, we should comment. We should use the test data first. Stop printing the sizes and then print the actual objects. know when I'm leaving, but it's not too far from today. How do I test it? This I have to test it by first. Um, okay. So the available space is this. The the used space is that, and that should sum up to 70 million, right? Okay. And so we can call it on this and run this now. 249, which is the D directory. Good. The D directory, right? The size is this. Okay. And now let's try and delete this. Sorry, let's try and uncomment this and run this. Okay, now let's look at the directory HDH. 5 million sounds about right. 56 million is what needs to be deleted. Okay, and so there we go. Yeah, I am dreading today. Like, what a terrible day today has been. Um, let's go and see the leaderboard. Um, I'm probably the last one to submit. So okay, and people are still struggling with it. So which is a good thing, right? Okay, so I mean, not really a good thing. Like, which just shows that today is incredibly rough. Yeah. So yeah, I'm definitely pushing this data up to everyone on my GitHub. So yeah, I'll see you same time tomorrow. Please do check out the code if you want to. Let me comment a lot of the print statement that I put in the thing. Yeah, what did I do now? Okay. Yeah. So yeah, see you same time tomorrow. Bye bye.